Welcome, everybody. And we are in our discussion about the mole and stoichiometry. We finished the mole last time, so let us move on to some more calculations we can do with the mole. So let us consider this. Consider silver hypochlorite. What is the percent of silver in the compound? What is the percent of chlorine in the compound? Egads, I'm not sure how to do this. Well, I think we're going to need some notes, right? So let us put up some notes here. We're talking about the mole, right? And we've already talked over here about the definition. We said, what is the mole? It is a measure of number. It is Avo's number of particles. Good. And then we did some basic conversions, right? Conversions. And we said we can go from particles, atoms or things like that, to moles by dividing by Avo's number. I can go from moles to, say, ions. How? By multiplying by Avo. I can go from grams to moles. How? By dividing by my molar mass. And I can go from moles to grams by multiplying by molar mass, right? So we've talked about definition, we've talked about conversion. Let's talk about some specific calculations that we can do involving the mole. And one of those is something we call percent composition. Percent composition. Okay, and where do I always like to start with these kinds of things? We want to define what is percent composition. It is the percent by mass. Important. It's not the percent by volume. It's not percent by mole. It's the percent by mass of one component in a compound. Okay, so that is my definition. It's a good definition to know. Just remember the key word is by mass. If you remember that, we can handle the rest probably without even needing a process. But let's go ahead and take a process. So what's the process by which we are going to do these percent composition questions? Now, you can use any other method. This is the way I like. Number one is I'm going to assume I have 1 mole of compound. Good. Once I make that assumption, I use my formula to determine moles of each component in compound. Three, calculate grams of component or components. Component of interest by doing what? Taking my moles, multiplying by the molar mass of the component. Right? Moles of component times the molar mass of the component. I'm going to calculate total mass of compound. How? Hey, I'm going to take the moles of compound, which is 1, times the molar mass of compound. Hey, good. So here I have the mass of my compound. I have my total mass. What do I have to do to get a percentage? I'm going to take mass of my component, or grams of my component, divided by total mass, which is grams times 100. There we go. And that'll give me my percent comp. So those are the 5 steps and right here, really determine really it's just the component of interest here. Determine the moles of component in the compound. Component of interest, whatever that is. That's all there is to it. Here we go. Let's do this. I have silver hypochlorite. What is the percent of silver? Okay, first thing we have to know is what is silver hypochlorite? Hypochlorite is ClO minus silver is Ag. It is going to be a +1 as an ion. So what is my formula? AgClO. Good. Now, I'm going to assume that I have 1 mole of silver hypochlorite. Good. Then how many moles of silver do I have? Well, I look at my mole ratio. I look at my formula. That means I have 1 mole of silver. That means I have 1 mole of chlorine. It means I have 1 mole of oxygen, right? Good. Now, let's get grams of silver. How do I get grams of silver? Well, grams of silver is going to be moles of silver times what? Well, times its molar mass. Molar mass of silver, where's silver? How about 107.87? 107.87. 107.87 grams per mole. And so what do I get? I have 107.87 grams of silver. Now, how do I get grams of my silver hypochlorite? Well, I'm going to take my 1 mole of silver hypochlorite times what? The molar mass. So I have 107.87 grams per mole plus, what's my molar mass of chlorine? Molar mass of chlorine is 35.45. I'm going to go with 35.45, and 16.00 is the molar mass of oxygen. Good. Let's add those up. Get out my handy dandy calculator here. Yoink. 107.87 plus 35.45 plus 16. And I get what? 159.32 grams of compound of AgClO. Good. Now what do I want to do? I want percent silver. So my percent silver in silver hypochlorite is equal to what? 107.87 grams of silver per what? 159.32 grams of silver hypochlorite times 100. And what do I get? So I take the inverse of that times 107.87 equals times 100. And I get, ooh, cool, 67.71%. Yee! Good. Now, how is this different for the next part? I want the percentage of chlorine. Well, what am I going to do? I have how many moles of chlorine in this? So I have 1 mole of chlorine. So I want to get grams of chlorine. Grams of chlorine is equal to 1.000 moles of chlorine times the molar mass of chlorine, 35.45 grams per mole. Right? I got that from the periodic table, but it also shows up right there. And so that means I would have what? 35.45 grams of chlorine. So what's my percentage? Percent comp of chlorine in silver hypochlorite is equal to 35.45 grams. Chlorine divided by what? 159.32 grams of silver hypochlorite times 100. And what do you think that is? Okay, 35.45 divided by 159.32 times 100. And I get 22.25%, right? Good. And the rest must be oxygen. All right? That is how we handle percent comp. And sometimes they'll just say, the questions might be something like this: what is the percent of nickel? Or they might just say, what's the percent composition of nickel 2 nitrate? In which case, if they say, what's the percentage composition, they want to know what's the percent nickel, what's the percent nitrogen, what's the percent oxygen. We're being a little more specific here. Okay, here you go. You guys do this one. Bring me back when you're ready. Nickel 2 nitrate. Well, we have to know what nickel 2 nitrate is. Nickel 2 means what? It has a +2 charge. The ion does. Nitrate is NO3 minus. So what is my formula? Well, what's my least common multiple? 2. How many nickels do I need? I need 1. How many nitrates do I need? 2. So that means I have NiNO3 2. Good. Excellent. What is the percentage of nickel? Okay, so we will assume that we have 1 mole of this stuff. If I have 1 mole of this, that means I have how many moles of nickel? Well, it's a 1-to-1 ratio, right? So I have 1.00 mole of nickel. Hey, what if the question said what if, okay, well, hold on a second. Well, I'll finish this and then I'll come back to it. 1 mole of nickel, and I want to get grams of nickel. So grams of nickel equal 1 mole times what? The molar mass of nickel. Nickel, 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 nickel. Right there. 58.69. 58.69, that's not a negative. 58.69 grams per mole of nickel. And so I would have 58.69 grams of nickel. I assume I have 1 mole of my nickel 2 nitrate. So I have 1.000 mole of nickel 2 nitrate. So I have to multiply that. I want grams of nickel 2 nitrate. How do I get that? I need to multiply by its molar mass. So that'd be 58.69 times what? Well, I'm going to have plus 2 times my nitrate. So nitrogen is what? Go to nitrogen. 14.01. 14.01 plus what? Well, it's 3 times oxygen, but I have 2 of those whole things, so it's really what? 6 times, oops, not 6, I'm sorry, I already have the 2 there, sorry. 3 times oxygen. Ooh, that was almost a mistake, right? You guys follow here? This 2 goes with that 2. So I'm going to multiply my nitrate by 2. Wow, I almost made a mistake there. Yikes. Okay, good. So this is my 1 nitrogen. This is my 3 oxygens. Okay, I did that right. So let's run the numbers, and what do we get? We get 1.000 mole times what? 3 times 16, and that's 48, plus 14.01, got it. That's 62.01 times 2, yes, got that, plus 58.69, and I get 182.71 grams per mole, which is equal to then 1 times that is 182.71 grams of nickel 2 nitrate. And then what's my percentage of nickel? Well, percentage nickel is equal to 58.69 grams of nickel over what? My total, 182.71, that's 182.71 grams times 100. That's of nickel 2 nitrate. And what do I get? How about 32.12? 32.12%, and that is of nickel in nickel 2 nitrate, right? 32.1%. Now, here's the question. How would we set this up if the question wanted percentage nitrogen? Well, percentage nitrogen, I have 1.000 moles of nickel 2 nitrate, right? Well, then how many moles of nitrogen do I have? Well, I have 1 mole of this whole thing, but there are what? 2 moles of nitrogen in every 1 mole of that, so I'd have 2.00 moles of nitrogen. So we'd have to work from the 2.00 moles. Everyone follow that? How many moles of oxygen do I have in 1 mole of nickel 2 nitrate? Well, I have 3 in my nitrate, and I have 2 nitrates, so I'd have 6 moles of oxygen. Just to remind us all how to do this. Got it? All right. I think it's good enough for now. This is all you need to know about percentage comp. Next time I see you, we'll talk about empirical formula. See you, folks.